Oops, my camera wasn't there. Sorry, everybody. Hi, everyone. I'm Mr. Matt, and this is Dr. Tot. And welcome to SAT, ACT Prep. Thank you for signing into my live stream. Today, we're going to talk about operations with radicals. We're going to learn about adding, subtracting, multiplying, or dividing by radicals. Also, simplifying radicals. Make sure that they have common radicants, and we'll talk about when we need to use that, or make sure that that exists. Make sure that the radicants match each other. And we're also going to solve some equations involving radicals. We're going to talk about the different indices too, so the square root, the cube root, the quartic root, and look at different examples. Yeah, thank you very much, Mark. I got your comment. Yeah, thank you. Everything's okay. He just had, he's actually the administrator here. His name is Ulysses, and he is going through some medical treatments, but everything's okay. We just had a little bit of a scare yesterday, so I appreciate everybody's understanding, and I'm working really hard to get the lessons that we missed yesterday up, recorded and posted for you all. So if you find these streams helpful, then go ahead and like and favorite the stream, and don't forget to subscribe to my channel. There's a watermark in the lower left-hand corner that you can click. That's a little bit of a shortcut that you can do that with. With no other ado, let's go ahead and look at some problems. And again, this is a live stream, so there's a little bit of a delay with my digital screen, my iPad here, so I do apologize. I'll try and keep track of all of that. If you ever need me to scroll up or down, just let me know in the live chat. And if you're watching this recording, if you have any questions at any point, feel free to post them in the comments below. Okay, so overall, remember that rules with radicals are similar or parallel or can be memorized or remembered with the rules of fractions. So they're very similar. The rules of radicals are similar to the rules of fractions. When we add or subtract fractions, we have to have common denominators. When we add or subtract radicals, we have to have common radicants. The radicand is the number underneath of the radical, the value, doesn't have to be a number. The value underneath the radical sign. The radical sign is the little check mark. Looks like the division sign, the longhand division sign, but has a little arm. And the value outside of the radical is called the coefficient. So if we had something that looked like this, so this would be read as 2 root 3. So 2 here is the coefficient, and 3 is the radicand. And remember that whenever we don't list an index value, it's implicitly 2. So let me go ahead and just define all of these. Okay, so just a few definitions so we all know what we're talking about when I start labeling parts of these things. If you have any questions, then please let me know, but overall, you can remember the rules of radicals by remembering the rules of fractions. To add fractions, you need a common denominator. To add or subtract radicals, you need common radicants. When you multiply or divide fractions, it's just numerator times numerator over denominator times denominator. With radicals, it's going to be coefficient times coefficient, radicant times radicant. We're also going to talk about how to simplify radicals, and that's going to be in line with the rules involving the LCM, finding the LCM and GCF that we went through in lesson 3. Primarily the prime factorization of the radicants will give away what values can be factored out from underneath the radical sign and placed as a coefficient. But more on that in a little bit. If there's any questions, then please let me know. So as I said before, to add or subtract values with a radical sign, you must have common radicants. So the radicants are the numbers of values underneath the radical sign. If you have common radicants, then you keep the common radicand, add or subtract just the coefficient. So the radicand doesn't change. However, if you don't have common radicants, you're going to have to first simplify in order to get common radicants. The value underneath the radical sign has to be the same in order to add or subtract. So what we can do, I'm going to solve the first one here with you, and then I'll give you some time to look at the second one. So in order to simplify radicants, you want to break the radicand into the its prime factorization. So I'm going to take 294 and 216 and break them into their prime factorizations. So 294, if I take 294 and let's say I try 4, well, first of all, it's even, so I know that it can be divisible by 2. So 294 divided by 2 would be 147. 2 is prime, so I circle it, and I can't break that down anymore. If I look at 147, if you add the digits of 147, 1 plus 4 is 5, 5 plus 7 is 12. 12 is divisible by 3. So that's a rule of divisibility with 3 and also with 9. If you add the digits of the number up and that sum is divisible by either 3 or 9, then the number itself is divisible by 3 or 9. So I know this guy is divisible by 3. And that gives me, that gives me 49. 3 times 49 is 147. 3 is prime, and 7 breaks down into 49 breaks down into 7 times 7. 216, if I take 216 and divide it by, let's say, I know it's divisible by 2, but let's try 4. You get 4 times 54. The larger the factors you use at each step, the less steps you'll have to go through. 54 is 9 times 6. 6 breaks down into 2 times 3. And 9 breaks down into 3 times 3. So these are the prime factorizations of 294. So I can rewrite these values as 4 times the square root of 2 times 3 times 7 times 7 plus 3 times the square root of 2 times 2 times 2 times 3 times 3 times 3. And the rule here for simplification is that if you're talking about the square root, as we are here, then for each pair underneath of the radical, you can bring 1 out. Because notice 7 times 7 is the same thing as 7 squared, and the square root of 7 squared is 7. They cancel each other out because they're opposite operations. So for each pair of values that we find underneath of the radical, we can pull 1 value out as a coefficient. So this is going to turn into 4 times 7 times the square root of 2 times 3 plus 3 times 2 times 3. Oops, let me get some more room here. Times the square root of 2 times 3. Notice that we're left these values, oops, let me get another color. This 2 and the 3 follow down because they don't have pairs to match with to pull out of the radical. So they're left underneath. And notice that that leaves us with common radicants. Because now 4 times 7 is 28. We have 28 root 6 plus 3 times 2 is 6. 6 times 3 is 18. So this simplifies into 28 root 6 plus 18 root 6. Now we have common radicants, so we keep the common radicants. Our answer is going to have a root 6 in it. and then we add the coefficients. 28 plus 18 is going to be 46. So our final answer here is going to be 46 root 6. If you have any questions, then please let me know. Otherwise, I'm going to leave that work up and I'm going to give you 3 minutes. I'd like you to look at that problem in the upper left-hand corner. It's 20 times the square root of 28 minus 2 times the square root of 112. So I'd like you to find common radicants, then do the operation, do the subtraction, and make sure your answer is in simplified terms. I'll keep track of the time in the upper right-hand corner, but I'll give you 3 minutes and then I'll start solving the problem. Okay, so looking at this problem, we need to get common radicants. Right now, the radicants are 28 and 112. Those are not the same value, obviously, so we need to factorize both of them to see if we can simplify here. So taking the prime factorization of 28, 4 times 7 gives you 28. 4 breaks that into 2 times 2. Excuse me. So we can rewrite the first term as 20 times the square root of 2 times 2 times 7, because 28 is the same thing, or is the same thing as the product of 2, 2, and 7. That's the prime factorization of the composite value 28. The second term, 112, will break down into 7 times 16. 7 is prime, so we can't break that down anymore. But 16 breaks down into 4 times 4, each of which break down into 2 and 2. So we can rewrite the second value as 2 times the square root of 2 times 2 times 2 times 2 times 7. Remember that for each pair underneath of the value, underneath of the radical sign, you can pull 1 out as the coefficient. So this is going to turn into 20 times 2 times the square root of 7 minus 2 times 2 times 2 times the square root of 7. Let me get some more room there. Twenty times 2 is 40, so this is going to turn into 40 root 7 minus 2 times 2 times 2 is 8. Now we have common radicants, so we keep the common radicant, subtract the coefficients. So this is the same thing as 40 minus 8 times the square root of 7. 40 minus 8 is 32. So your answer here would be 32 root 7. If you have any questions, then please let me know. Otherwise, I'm going to give you 3 minutes. I'd like you to look at both of the next questions. So the first question is 5 root 44 plus 4 root 99. And the second question is 9 root 325 minus 8 root 208. I'll give you 3 minutes, then I'll give you the solutions. Okay, so looking at the first value, I factorized 44 and 99 in blue. 44 breaks down into 4 times 11. 11 is prime, but 4 breaks down into 2 times 2. 99 breaks down into 9 times 11. Notice the repetitive 1s and 10s value gives away that it's a multiple of 11. And 11 is prime, but 9 breaks down into 3 times 3. So we can rewrite this guy as 5 times the square root of 2 times 2 times 11 plus 4 times the square root of 2 times 2 times 2 times 2 times 11. Remember that for each pair, you can bring 1 outside. So this is going to turn into 5 times 2 times the square root of 11 plus 4 times 2 times 2 times the square root of 11. 5 times 2 is 10, so this is going to turn into 10 root 11. 4 times 2 is 8, 8 times 2 is 16, so this is going to turn into 16 root 11. Now we have common radicants, so we keep the radicand, add the coefficient, so this is going to be the same thing as the square root of 11 times 10 plus 16. 10 plus 16 is 26. So your answer here is going to be 26 root 11. If you have any questions, then please let me know. For the second question, 9 root 325 minus 8 root 208. 325 breaks down into 13 times 25. 13 is prime, but 25 breaks down into 5 times 5. So we can rewrite this guy as 9 times the square root of 5 times 5 times 13. And 208 breaks down into 13 times 16. 13 again is prime, but 16 breaks down into 4 and 4. The two 4s each themselves break down into 2 and 2. So we can rewrite the second value as 8 times the square root of 2 times 2 times 2 times 2 times 13. Again, for each pair underneath, we can take 1 outside. So this is going to simplify into 9 times 5 times the square root of 13 minus 8 times 2 times 2 times the square root of 13. Nine times 5 is 45. 8 times 2 is 16. 16 times 2 is 32. So we end up with 45 root 13 minus 32 root 13. Now we have common radicants. Keep the radicand, add or subtract the coefficient. So this is going to be 45 minus 32, which is going to be 13. So this is going to be 13 root 13. If you have any questions, then please let me know. Otherwise, let's move on to multiplication and division. So remember, with multiplication and division, we don't need common radicants. Just like with multiplication and division of fractions, we don't need common denominators. We just multiply straight across with multiplication. And with radicants, you're going to do the same type of thing with division. I know division of fractions we usually go about by multiplying by the reciprocal of the denominator. With radicals, you just do coefficient divided by coefficient, radicand divided by radicand. And the same thing with multiplication. Just coefficient times coefficient, radicand times radicand. The number outside the radical times the other number outside the radical times the square root of the number inside the radical times the other number inside the radical. So they all correspond. So I'm going to give you 3 minutes. Take a look at these two questions, and at about 1.5 minutes, I'll start to solve them. Okay, looking at the first problem, we have 13 root 5 times 3 root 3. So we're going to just multiply coefficient times coefficient, 13 times 3, times the square root, or the radical, the square root of the radicand times the radicand. So the square root of 5 times 3. 13 times 3 is 39. 5 times 3 is 15. 15, because it's the product of two prime numbers, 5 and 3, we can't break those down anymore. And as they're written, there are no pairs of fractions underneath the radical sign. So this is already in simplified form. That's not true, however, for the second value. 63 divided by 9 is 7, and 24 divided by 3 is 8. But notice that 8 can be broken down into 4 times 2, and 4 can be broken down into 2 times 2. So this is the same thing as 7 times 2 times 2 times 2. So this is not written in simplified form because I have these these pairs of 2 that can come outside of the radical. So our answer here, whoops, that's not what I wanted. So our answer here is going to be 7 times 2 times the square root of 2, which is 14 root 2. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. I'd like you to look at the next two problems. The first problem is 12 root 3, no it's not, I'm sorry, 12 root 6 times 4 root 4. And the second problem is 72 root 24 divided by 12 root 6. I'll give you 3 minutes. Okay, so let's look at the first problem. 12 root 6 times 4 root 4. So coefficient times coefficient would be 12 times 4. Radicand times radicand is going to be 6 times 4. So 12 times 4 is 48. 6 times 4 is 24. Now we want to make sure that that's written in simplified form. So if we look at the factorization of 24, that's going to be 2 times 12. 12 breaks down into 3 times 4. 4 breaks down into 2 times 2. So this is the same thing as 48 times the square root of 2 times 2 times 2 times 3. And we do in fact have a pair of 2's in there that we need to pull out. So that's going to be 48 times 2 is 96. So our final answer here is going to be 96 times the square root of 2 times 3 is 6. So 96 root 6. For the second problem, 72 root 24 divided by 24 root 6. 72 divided by 12 is 6. 24 divided by 6 is 4. Now notice that 4 is a perfect square. So the square root of 4 is actually 2. It evaluates just into the number 2. 6 times 2 is 12. So your answer to the second problem is actually just the value 12. If you have any questions, then please let me know. Next, I want to talk about rationalizing the denominator. And so in most SAT problems, we're not going to want to leave a radical in the denominator at all. It's considered inappropriate, or it's not, at least it's not going to be available in most multiple choice questions. So you need to be able to rationalize that, and you do that by multiplying by a fraction equivalent to 1, where the numerator and denominator is the radical itself. So for example, if we look at this first value, let me make that bigger here. So if I multiply for the first value, for the first question, we'll do these together. I'm going to multiply, I'm going to get rid of that denominator of root 12. So I'm going to multiply by root 12 over root 12. You need to make sure that you apply that equally to the numerator and to the denominator, and to all values in the numerator and denominator if there's more than one. So we're going to have 8 root 2 times root 12. Remember, just radicand times radicand, so that's going to turn into 8 times the square root of 2 times 12, plus 6 root 12, because the root 12 and the 6 can't multiply into each other if they're not the same type of value. 6 is a coefficient, is a real value. 12 is a radicand. Now, when we multiply root 12 times root 12, notice that that's the same thing as 4 times the square root of 12 squared. And that's the whole point here, because it cancels out the radical in the denominator. So we're going to have 8 times the square root of 24 plus 6 times the square root of 12, quantity divided by 4 times 12. And that would simplify into 8 root 24 plus 6 root 12, quantity divided by 48. And now you would just need to simplify. So we want to make sure that we can't pull out any common pairs. So we need to factorize 24 and 12. 24 will be 3 times 8. 8 is 4 times 2. And 4 is 2 times 2. 12 is 3 times 4, and the 4 breaks down into 2 times 2. So this will simplify here, because this is the same thing as 8 times the square root of 2 times 2 times 2 times 3, plus 6 times the square root of 2 times 2 times 3. So we can pull these factors out. Each of these pairs of 2's will come out, so we'll have 8 times 2 times the square root of 2 times 3 plus 6 times 2 times the square root of 3. And that's still quantity, sorry, I dropped the 48 there. My bad. Remember, this is all still quantity divided by 48. So multiplying 8 times 2 is 16, so we get 16 root 6 plus 6 times 2 is 12, 12 root 3, quantity divided by 48. And you can see all of those values are also, all of the coefficients now are divisible by 4. So we can pull a 4 out. So this is going to be, I'm just going to continue this down here to the left. So I'm going to pull a 4 out of the numerator, so that's going to give me 4 root 6 plus 3 root 3. Remember, when you pull a value out, you put the value on the outside of the set of parentheses and you divide each of the original values by that value. So 16 root 6 divided by 4 is 4 root 6. 12 root 3 divided by 4 is 3 root 3. And I can pull a 4 out of the 48 as well. That's just 4 times 12. Notice now the 4's will cancel, and your final answer here would be 4 root 6 plus 3 root 3, quantity divided by 12. And I also want you to be able to recognize that this is the same thing. They could write this as 4 root 6 over 12 plus 3 root 3 over 12. And that way it would simplify, because notice this would be root 6 over 3 plus root 3 over 4. So you have to be able to recognize that all of these forms are equivalent values, because oftentimes the value that you end the calculation with will not be the value that they present the answer selection in. So you need to be able to evaluate equivalent forms. Okay, if there's any questions, then please let me know. That was the first problem. I'm going to give you 3 minutes. I'd like you to look at the second problem there. And if you need me to scroll up or down, please just let me know in the chat function. But I'll give you 3 minutes, and I'll keep track of the time in purple up at the top right. Okay, so let's look at this second problem. Let me erase this here to give us some room. Okay, so I need to rationalize this denominator. That means I want to get rid of that square root of 2. So I'm going to multiply by root 2 over root 2. Because remember that root 2 over root 2 is just something divided by itself, which is 1. 1 times anything is that same something. So you're not changing the value here. You're doing the same thing to the numerator as you would to the denominator. So this is completely valid. Just make sure that you get the root 2 to that 6 root 5 and to that negative 3, as well as to that root 2. So this is going to turn into 6 times the square root of 5 times 2 minus 3 times the square root of 2 divided by 7 times the square root of 2 squared, because it's root 2 times root 2, something times itself. 5 times 2 is 10, so this is going to be 6 root 10 minus 3 root 2, quantity divided by 7 times root 2 squared is just 2. So this is going to turn into 6 root 10 minus 3 root 2, quantity divided by 14. Now, 3 in the numerator, that coefficient of 3 is not even, and it's separated from the 6 root 10 with subtraction. So whenever two values are separated by either addition or subtraction, you have to consider them kind of like married to each other, or they're bound to each other in a certain way where you have to pull the same value or be able to pull the same value out of both of them if you wanted to simplify by a certain term. So 3 is prime and it's odd. 6, there's no factor that's divisible or that goes into 3, 6, and 14. So therefore this is already in simplified form. The 10 is only divisible by 2 and 5, so it's not going to result in any pairs underneath the radicand that would simplify any further. So this is your final answer. 6 root 10 minus 3 root 2, quantity divided by 14. What you could do is separate them. So this could be written as 6 root 10 over 14 minus 3 root 2 over 14. And that would allow you to simplify out the 2, the factor of 2 in the first term. So that would be 3 root 10 over 7 minus 3 root 2 over 14, because you couldn't do anything with the second term. So just know that these are all equivalent forms, but as long as you got one of them, then I'd be happy with that. If you have any questions, then please let me know. I have two problems here. Let me get rid of this. I'm going to give you 5 minutes, and at about like minute 3, or excuse me, about like minute 2 into the 5 minutes with 3 minutes remaining, I'll start to solve the problem, because I want to make sure that we get into some equations as well. So 5 minutes, after 2 minutes I'll start to solve. Okay, so for the first value, we have 10 root 5 minus 5, quantity divided by the square root of 125. So I'm going to multiply by root 125 over root 125. When I do that, that's going to give me 10 times the square root of 5 times 125. 5 times 125 is 625. Then, so I get 10 root 625 minus 5 root 125 as my numerator. Excuse me. In the denominator, I'm going to get root 125 times root 125. Those will ultimately cancel out because the root of 125 squared are opposite operations. And so that's going to result in a denominator of just 125, the integer value 125. In the numerator, however, we can break up 625 and 125 into its prime components. 625 is actually 5 to the 4th power, so there's 4 5s underneath of the radical sign. So we have 2 pairs of 5s, so we can bring 2 5s outside, resulting in 10 times 5 times 5, which is going to simplify into 250. We can pull 1 5 out of the second term, so that's going to end up being 5 times the square root of 5, which is just 25 root 5. That's still all divided by 125, so I pulled out a factor of 25 to simplify, and that left me with the value 10 minus root 5, quantity divided by 5. For the second value, notice how we got this very large number. We have the square root of 32 times 128. I'm not going to multiply that out right away. I'm just going to leave it as 32 times 128 because that's going to be a really large number, and I'm going to try and simplify that at some point, so it's needless to write that all out. So if I go ahead and think about those values, 32 is 2 times 16, which is 4 times 4, which is 2 times 2 and 2 and 2. So it looks like the first value is just a whole bunch of 2's, because notice 128 is divisible by 32. So 4 times 32 is 128. So this guy is just a whole bunch of 2's as well. That would break down into 4 times 8, 2 and 2. 8 breaks down into 2 times 4. That breaks down into 2 and 2. So you're going to end up just with a whole bunch of 2's here. So this is the same thing as 9 times the square root. 32 has 5 2's. But instead of writing 2 times 2 times 2 times 2 times 2, I'm going to write this, use our rules of exponents. I'm going to write that as 2 to the 5th power. Now that's multiplied by 128. 128 is just an exponentiation of 2 to the 1, 2, 3, 4, 5, 6, 7th power. 128 is the same thing as 2 to the 7th power. So you can see the convenience of using the rules of exponents, otherwise this would be a super long string of 2's. Plus 3 times 128, again, we just solved that to be the same thing as 2 to the 7th. And this is over 128 because the square root and the square will cancel out. Notice underneath of the radical, we have common bases raised to exponents and we're multiplying. It doesn't matter that these values are underneath the radical sign. We still have common bases and we're multiplying, so we can use the rules of exponents where we keep the base and add the exponents to get the result. So this is the same thing as 9 times the 9 times the square root of 2 raised to the 5 plus 7 power. Five plus 7 is 12, so this is 9 times the square root of 2 to the 12th plus 3 times 2 to the 7th. Quantity over 128. Remember that the square root is the same thing as raising something to the 1/2 power. So I can actually simplify this further by 9 times 2 to the 12th quantity raised to the 1/2 power. And let me move this down here actually. Plus 3 to the 2 times 2 times 2 times 2 times 2 times 2 power, all over 128. And we have these pairs of 2. Oops, I need one more 2 here. That will all come out of the radicand. 12 times 1/2 is 6, so this is the same thing as 9 times 2 to the 6th power plus 3 times 2 times 2 times 2 times the square root of 2 over 128. 2 to the 6th power is 64, so this is the same thing as 9 times 64 plus 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. This is 24 root 2, quantity over 128. And lastly, we have, let's see if 128, we have a common factor of 9. So let's see if 128 is divisible by 9. It's not. Let's see if 128 is divisible by 3. It's not. So this is going to be in final form. Except, well actually, we have 64 there. Let me see 24. 64. Well, actually, we have 8. 128 divided by 8 is 16. So this is actually going to, we can pull an 8 out of all of this. So this would be 9 times 8 plus 3 root 2 over 8 times 16. And the 8s would cancel. 9 times 8 is 72. So your final answer here, this was a long one. Your final answer here would be 72 plus 3 root 2 quantity divided by 16. So that one was super long. That is not usual for an SAT problem. I kind of threw in all the nuts and bolts in that last one. So that's why it was so particularly long. But if you have any questions, please let me know. I do want to make sure that we get through a few problems that contain equations. So let's look at the problems that are labeled here 9 and 10. I'm going to solve 9 with you, and then I'll leave you some time to solve 10, and then we will probably be able to get through at least one more before the end of session today. So for 9, I want to solve for b here. So if I take this guy, actually what I'm going to do, let me just put this guy down here, and then I'm going to do this, because I only need one of them right now. Okay. So this looks super complex, but notice you have common radicants. Your radicants, the values underneath the radical sign, they might be really, they're not in terms of one single numeric value, and they're not even in terms of one unknown variable. Excuse me, they are in terms of one unknown variable, but they are not itself one variable. It's some expression that's underneath the radical sign. So it seems really complex, but remember, we don't really need to worry about the radicand until we've already dealt with the radical sign. And we can use all of the operations with radicals as long as we have common radicants. So I could move that -4 to the left by adding 4 on both sides. So it eliminates on the right-hand side. 12 plus 4 is 16. So I'd get 16 plus 3 times the square root of 2b minus 4 is equal to 7 times the square root of 2b minus 4. Now I could subtract 3 times the square root of 2b minus 4. I can subtract this whole thing on both sides. And because they have common radicants, I can keep the radicand, add or subtract here the coefficients. So here, these values just straight up go away because they're equal magnitudes but opposite signs. 7 times the square root of 2b minus 4 minus 3 times the square root of 2b minus 4. Again, they have common radicand, so I keep the common radicand. That's 2b minus 4. Subtract the coefficients. 7 minus 3 is 4. So 4 times the square root of 2b minus 4 is equal to 16. Notice if I divide by 4 on both sides, then I'm going to get the square root of 2b minus 4 is equal to 16 divided by 4 is 4. But now I'm solving for b. So I'm going to take the square root of both sides because I need to get rid of that radical sign now. So if I square both sides, now I'm going to get 16 is equal to 2b minus 4. Adding 4 on both sides will cancel out the 4 on the right. And now I'm going to have 20 is equal to 2b. So I can divide by 2 and find that b has to be equal to 10. I'll give you a few moments to make sure that you get that work down. If you have any questions, then please let me know. Otherwise, take a look at the question labeled number 10, which I'll crop here to get rid of 9. And I'll try and leave that up so you have all the work available to you. But otherwise, I'll give you 3 minutes. Please complete question number 10. That's labeled number 10. And then I'll give you the solution. And I'll keep track of the time here in teal. Okay, so for number 10, started to solve it there if you're following along. So first, if we just add 14 to both sides, then the 22 on the left becomes 36. And then we can add 4 times the square root of 2w plus 3 on both sides. That combines with the 8 times the square root of 2w plus 3 on the right-hand side to create 12 times the square root of 2w plus 3 is equal to 36. Dividing by 12 on both sides, 36 divided by 12 is 3. So then we get 3 is equal to the square root of 2w plus 3, and I square both sides to get rid of that radical. When I do that, I get 9 is equal to 2w plus 3. Subtracting 3 on both sides, I get 2w is equal to 6. Dividing by 2 finally gives me w is equal to 3. If you have any questions, then please let me know. Otherwise, let's take a look at these last two problems of the day. I'll give you 5 minutes. After about 2 minutes, I'll start solving them, and then we'll review these problems, and then that'll bring us up to the end of class today. Okay, so 5 minutes. Okay, so number 11, negative 20 plus the square root of 6z minus 8 is equal to 60 plus 11 times the square root of 6z minus 8. So we do have common radicants here, so we can combine these complex values. Just remember that you have a coefficient of 1 here. When you don't have a coefficient, it's implied to be 1. So just watch out for that. So when I add 20 to the right-hand side, well, when I add 20 to both sides, it eliminates on the left-hand side, but adds to the right-hand side. So 60 plus 20 is 80. So, oops, I wanted my highlighter there. So that's where I got this 80. And then we're going to subtract 11 times the square root of 6z minus 8 from 1 times the square root of 6z minus 8. That's going to be negative 10 times the square root of 6z minus 8, because that's 1 minus 11. That's going to be negative 10. So, dividing by negative 10 on both sides is going to give you the square root of 6z minus 8 is equal to negative 8. That's right here. Then I took the not the square root, I squared both sides to eliminate the square root. So 6z minus 8 is equal to 64. Adding 8 on both sides, I'm going to get 6z is equal to 72. Dividing by 6 on both sides, I get z is equal to 12, which is our final answer. For number 12, 14 times the square root of 7j minus 6, quantity plus 72, is equal to 30 times the square root of 7j minus 6, quantity minus 56. So when I add 56 on both sides, that's going to turn into 72 plus 56 is 128. And then when I subtract 14 root 4j minus 6 from 30 root 7j, excuse me, that should be 7j. Why did I write 4j there? My apologies. This should be 7j minus 6. I'm sorry, because they have to have common radicants to do any of the addition or subtraction. When we subtract there, we get 16 times the square root of 7j minus 6. Dividing by 16 on both sides, 128 divided by 16 is 8. And then squaring both sides, we're going to get 64 is equal to 7j minus 6. And then we're simply solving for j there by adding 6 to both sides. That gives me 70 is equal to... Oops. Oh no, that's not what I wanted to do. Here, this is the step I'm talking about. Adding 6 to both sides gives me 70 is equal to 7j. And so then I just divide by 7 on both sides and find j to be equal to 10. If you have any questions at all, then please let me know. You can either type them into the live chat function, or you can leave them as comments below. But otherwise, I really appreciate everybody signing in today. We're going to continue on Friday with live stream 3 and continue with radicals. And we'll also I'll make sure to prioritize some more with rationalizing the denominator and solving with equations, especially involving the cube root, the quartic root, and raising or exponentiating values to the third or fourth power. Remember, when we do that, it's no longer 2 values underneath the radical that we need to pull 1 out. We need 3 for the cubic root, or 4 values underneath the radical for the quartic root to pull 1 coefficient outside. But more on that on Friday. If you found this helpful, then please like the video or like my stream and hit the subscribe button. But otherwise, Dr. Tot, you want to say goodbye to everybody? Come on, up. You say goodbye. You can get Paul. It's goodbye. He's having a little trouble today. Good boy. Very good boy. All right, thank you guys very much for signing in. I'll talk to you all tomorrow. The recordings of the sessions that we missed yesterday due to that medical emergency that we had here will be uploaded soon, so just check my channel for that. Thank you. Have a great day. I'll talk to you all tomorrow.